Well, welcome back. This is my ELM test prep series. I'm James S. And maybe you stumbled in, or maybe you're a continuing observer of my follies. The purpose of this, of course, is to prepare you to take the ELM PAT, the Elementary Level Math Proficiency Acceptance Test. Many universities and colleges are using this now, and so I'm talking about the things needed to pass this. This particular episode is episode 29, and we're going to be talking about Pythagoras, or the Pythagorean Theorem. Well, if you're a history buff of math, you know that the Pythagoreans were sort of a secret society for a long time, and their basic concept of life is that all life is math. And to some degree they were correct. Of course, there's a little more than that, but a lot of it is math, whether you like it or not. So the Pythagorean theorem deals with right triangles. A right triangle is a triangle that has a right angle or a 90-degree angle. One of the angles must be 90 degrees. Having established that, they then came up with ways to determine the relationship of the legs to one another, and C being the largest leg. C is always the hypotenuse. The hypotenuse is the diagonal. So C is always the largest leg. The diagonal will always be longer than either of the two legs. Always. Whether it's a square, if it were a square, obviously this distance is, if I were to pivot that, would be less than the diagonal. If it were rectangle, the same would be true. So the C leg is always the largest. Now you can call this A and B or B and A, but in terms of the Pythagorean formula, this will always be C. So the general formula is A squared plus B squared equals C squared. The Pythagoreans found that in right angles or rectangles or whatever, the diagonal across had this relationship to the sides. Now this leads you into a whole lot of trig as you delve more deeply into the idea of the right triangle and its relationships. Now understand, if I have 90 degrees here, that the remaining two angles when added together will be 90 degrees, because every triangle has 180 degrees. So if I took up 90 here, the remaining two must add, if it is in fact a triangle, must add to 90 degrees. If this were 30, this would be 60. And it's possible they would ask you, given this information, a certain amount of information, they might say, well, what is this angle down here? What is angle A? Now in general they use capital letters for the angles. This is angle C and this is angle B. And notice the angles are crossed or opposite to their side. Side C, angle C. Side A, angle A. Side B, angle B. That's always true in the particular way that we label things. So A squared plus B squared equals C squared. Well, if I just wanted to, I could reverse this and say, well, C squared equals A squared plus B squared. The only thing I've done is turn this around and write it the other way. And this is quite often the way you will see it. What if I only wanted to know C? Well, I'd have to take the square root of C squared to get C. So if I do that, I have to do the same thing to the other side. So quite often you'll see the value of C written that way. Well, that wasn't too complicated an idea. I want to get C squared to a C, and the way I get rid of a square is I take the square root, so I take the square root of both sides. Well, what if I wanted to find the value of A? Well, I have a squared, and I had c squared initially on the other side, and so I'm going to take the b to the other side as a minus b squared. Here again, if I'm looking for just a, I'm going to take the square root of this side and the square root of this side. So the leg a is equal to the square root of c squared minus the opposite leg. And quite often you will use that particular thing to find one of the legs. Okay, so Pythagorean theorem deals with right triangles, and the formula c squared equals a squared plus b squared, where these are the two legs and c is the diagonal. C is always the larger side. Well, it makes sense in terms of the formula. If c is equal to the sum of those, it would have to be the largest side. Now, some very common triangles that are nice to remember. It's called a 3, 4, 5. 3, 4, 5. If I square this, I get 9. If I square this, I get 16. And I add the two of those together, I get 25. Well, if I square this, I get 25. So c squared equals a squared plus b squared. So 3, 4, 5 is a common triangle that you might find on your problems. And if you find that, you just want to jump right on it. If they are asking you what c is, 3, 4, 5, you're done. If you knew that, you're good to go. Another common triangle is the one that's 1, 2, square root of 3. 1, 2, square root of 3. This happens to be a 30-60 triangle. And so if you know the relationship of 1, 2, square root of 2, 2 being the largest, if I squared 1, I get 1. If I square this, I get 3. 3 and 1 is 4, and 2 squared would equal 4, so it suits my formulary. So 3, 4, 5. Let me use a different color here. 3, 4, 5, or a 1, 2, square root of 3. Those are the most common triangles they throw at you in terms of these kind of problems. And we're minimizing our math here, so remember that ELM is no calculator kind of math. So you have to be good at just doing basic algebra and basic mathematics. Multiply, divide, add, and subtract. Okay, that's the Pythagorean theorem in a nutshell. And we will probably come across that a little bit in some specific kinds of questions. But for now, that's the end of this part. And specifically, I wanted to stay with the Pythagorean theorem. This is James S., and this has been another part of my ELM test prep series. Hope it was valuable. It was short and sweet and not too in-depth on the Pythagorean. We didn't attempt to prove the theorem that much, but we want to approach this from how can I answer my questions, and hopefully that will help you. Anyway, have a good day.